Alright, we are continuing with logarithmic functions. Something I want you guys to write down in your journal is whenever you guys see Ln, that refers to the natural log. Put Ln equals, it's the same as if I were to say log base e. So instead of saying log base e, we've changed to what's called the natural log. And natural log works with base e. That's what we're working with. Okay. Things you need to know about the natural log. If I were to write the log base b of b to the power of x, when these are the same base, your answer is just x. Now, yesterday we did something, all right? If I say log base b y equals x, if I wanted to change it from logarithmic form to exponential form, I would do this method. B raised to the power of x equals y. This is what you can do from logarithmic form to exponential form. Well, look what happens when I do this. If I say b raised to the power of x, what does that end up equaling? That ends up equaling b to the power of x. B to the power of x equals b to the power of x. Now, I'm trying to make a connection here with our problem that we're working on right now. If I were to rewrite this as log base e, what do I have? I have e to the power of 5. Are these the exact same base? Yes. What I want you guys to know is that when I say the natural log, that's the same as saying log base e. This e to the 5th is just e to the 5th n. So are these the same base? They are. So what does this have to become? This has to become a 5. Now the shortcut, everybody, the shortcut is this. Whenever you take the natural log of e to the power of x, that will just equal x every single time. So if you see the natural log of e to any power, that equals x. If I say, what's the natural log of e? That equals a 1 because this is e to the power of 1. All right? So these are a couple of patterns that you want to put into your journal. All right, to finish this problem, we're going to bring down the 2. This means 2 times all of this. Well, if all of this ends up equaling a 5, your answer is just 2 times 5, which is 10. Okay? So your final answer for number 4 is 10. Something for you guys to maybe see things a little bit differently in the graphing calculator. I'm going to go right here. I'm going to type in the natural log, all right? And I'm going to type in an e. Second division gets me to e. So the natural log of e is 1. If I went up here and say, what's the natural log of e to the power of 5, what do I get? I get 5. If I went up and said, what's the natural log of e to the power of 1, 2, 3? The answer would be 1, 2, 3. Now, what did I say the natural log was equal to? The log base e. So, everybody, alpha window number 5. Alpha window number 5. I can actually type in base e. Right there. Now, if I say e to the power of 1, 2, 3, what's my answer going to be? 1, 2, 3. Does everybody see how these right here are the same base? Okay? But instead of having to write log base e, what's all you have to write? Ln. ln stands for the natural log. So just remember, if I say ln, that's the same as saying log base e. All right, keep moving forward. Here is the pattern that I want you guys to write down for number 5 in your journal. I want you to write, if you have a base and it's raised to the log of that exact same base, then whatever number you have right here is going to be the answer. I'm going to do my best to explain why this is the case, okay? So this answer will be 18. Right. So number 5, these are the same base. So there's your number right next to it. That is going to be your answer for number 5. Okay? But I'm going to explain to you guys, hopefully, why that is the case. I'm going to highlight things in 3 different colors. And we're going to label them. So what I'd like you to do in your journal right now is I would like you guys to write base b raised to the power of log base b of x equals x. All right? I want you guys to write that down. Now, understand this right here. This value represents what my exponent is. This value here represents my answer. Okay? So if I were to change this to logarithmic form, okay? Just remember, we're going to go down here. I'm going to write 2 different things, okay? B to the power of x equals y. I'm going to write down log base b of y equals x. I'm going to color code it the exact same way. Here's my base. Here's my base. Here's my exponent. Here's my exponent. Here's my answer. Here's my answer. Okay. So right now, I'm going to write log. What is my base in this problem? What is my base? B. Log base b. Okay? Of. Okay? What's my answer over here? What's my answer? X equals. What is my exponent? What's my exponent? Log base b of x. So log base b of x ends up equaling what? Log base b of x. Now I'm going to highlight it in 3 different colors. This was blue. This was red. This was green. I'm going to move it over so you guys can see it. Okay? Blue, red, green. Blue, red, green. We go around the world. B to the power of log base b of x equals x. That's why the pattern works. So here's some examples right now. If I wrote down 7 log base 7 and I said 1, 2, 3, 4, that would equal 1, 2, 3, 4. If I said 8 log of 8 and I said of confused face, that would equal confused face. Alright? Alright? If I said 10 log 10 parentheses angry face. Alright? What's that going to equal? No, it's not going to equal confused face. It's going to equal angry face. Alright? Here, I'll make some evil red eyes. There we go. There's somebody who's really angry right now. Alright? So, if you have the same base, whatever's there is your answer every single time. I know, you could probably draw better. Okay. answer for this one, yes, has just been 18. Why did I do all the other work? So that you guys have some patterns. Right here, this is the pattern that you guys need to have in your journal. All right, so we're going to go over here to number 6. Number 6, put equals x. 8 raised to the power of x equals 32. Uh-oh. What did we change that? What did we change 8 to? 32. Now, everybody, something you're going to need to know, all right? Because you guys need to know that 8 can be converted to base 2. Because 8 is the same as 2 to the power of 3. 32 can be converted to the base of 2. Now, I'm not talking about counting bases. I'm talking about bases for your exponents. 2 to the power of 5. So right now, 2 to the power of 3 is definitely not equal to 2 to the power of 5. So what do I have to drop down? I have to drop down this x. Okay? So understand, right now, I have converted the number 8 to 2 to the power of 3. I have converted the number 32 to 2 to the power of 5. Okay? Now, here's the concept that you guys need to understand. If I have base b to the power of n, and I say that's equal to base b to the power of n, you need to know that this exponent must equal the exact same as this exponent. So n has to equal n if these bases are the same. Which means this 3x, right here, 3 times x, has to equal what number? It has to equal the number 5. So now that we know this, if these are the same, see how we made them the same? You see how these aren't the same? So what did I have to do? I had to make them the same. Okay? So since I made them the same, I can write down 3x equals 5. What does x have to equal if we divide both sides by 3? 5/3. And that's your answer. Now how does that make sense? Let me show it. Take 8, raise it to the power of 5 divided by 3. You're not going to believe what you could do. So what does that tell us? That tells us we found, if the question was 8 to the power of x equals 32, what does x have to be? 5/2. I know. That was a yawn of excitement right there. A yawn of excitement. Okay. Now, we have lots of yawns of excitement in this class, I'm telling you. There's just tons of excitement. So, right now, everybody, what I'd like you to do is I would like you guys to write this. B log base b of x equals x. Right, you did that, right? Now, did everybody see this ln right here? So what I want you guys to do is rewrite it. So maybe it makes a little bit more sense. Ready? Write e. Instead of writing ln, write log e of 0.014 x. Do we have the exact same base? We do. So following the exact same rule, if this base matches this base, what is our answer? Our answer is just whatever is right next to it. What is right next to this? That's your answer. Now, why is this one difficult? Because you guys don't automatically see the natural log as what? As a base e. So what did I do? I converted this to log base e. And that's your answer. Do you see how you can't use the calculator for that? You can't just type it in the calculator and press enter. Everybody? 144 can also be rewritten as 12 squared. So I want you guys to rewrite number 9 as this. Log base 12 of 12 squared and put equal, to set it equal to x. Set it equal to x. And then I want you to go around the world and change it from logarithmic form to exponential form. So I'm going to say 12 to what power? 12 to the power of x equals, very good, 12 to the power of 2. And voila. What does x have to equal without even using a calculator? 2. See right here? That's your answer. X has to be 2. The last problem we're going to be doing today on this video, all right, is problem number 10. Problem number 10. So right now, get your graphing calculators ready to go. What we're going to do right now is we are going to first change our window settings. So just change your window settings with me. Right here, we're going to go. I'm going to write down what our window settings are going to be. Over here, our x maximum is going to be a 10. Our x minimum is going to be a negative 10. Our y max will be a 21. Our y minimum is going to be a negative 9. Just so you know, our x scale is going to be 2. And our y scale is going to be a 3. Why is that? Because these are counting up by 3s. And these are counting up by 2s. So go to your window setting right now. Hit window. Change it with me. Going from negative 10 to positive 10. X scale 2. Y minimum. What did I say y minimum is going to be? Negative 9. Y maximum, I think I said, is going to be a 21. And our y scale is a 3. Now go to y equals. We're going to type in our function. Okay? Right now your graph should look like this if the grid lines are on. So if your grid lines are not on, make sure you hit second zoom. Turn your grid lines on if they're not on. Hit y equals, I'm going to say 4 to the power of negative x plus 2. Hit graph. Now, there are certain points I want us to try to plot on our paper. The points that I want you to attempt to plot. Oops, not right there. Second window, I'm going to start at 0. So here's some points I'd like you to plot to the best of your ability. A 0, 16, a 1, a 4, and a 2 and a 1. So 0, 16, I'm going to put right about here. All right, we had a 1 and a, what was it? 1 and a 4. Okay, so I'm going to go 1 and a 4, which is going to be right about in there, and then a 2 and a 1 right about here. Graph like this. Just make sure you don't go across the x-axis. You're just getting closer and closer and closer to it. So there's your graph. We're going to talk about the left end behavior and the right end behavior. So I'm going to set it up. I'm going to write limit of f of x. Just so you know, or actually not f of x. Instead of g of x, I'll say the limit of g of x. There you go. The limit of g of x, right, equals something as x approaches negative infinity. So just remember, on the left end behavior, what's x always approaching on the left end behavior? Negative infinity. What's x always approaching on the right side? X always approaches positive infinity. So right. The limit of g of x equals something as x is approaching positive infinity. So as x is going this way, where are my y values going? Are they going up, down, left, or right? Up here? Where are they reaching? They're going where? They're going to positive infinity. So as the x values are going to the left, the y values are getting bigger and bigger and bigger, going towards infinity. As the x values are increasing, what are the y values getting closer and closer and closer to? So the limit of g of x equals 0 as x approaches infinity. So that's what the right-hand behavior and the left-hand behavior is. All right, so remember this graph. What we're going to do is we're going to look at the other answers. I'm going to zoom out just a bit, okay? I'm going to sketch this, just it's not going to be the same exact graph. It's not as nice. All right, we've already done left-hand behavior and right-hand behavior. What's our domain? What x values are being plotted? Is this a continuous function? It is continuous. So if it's continuous, that means all of my x values are being plotted. So my domain means all real numbers in interval notation. Are all of my y values being plotted, or is there a limit to my y values? What's the lowest that it's going towards? What's the lowest? 0. Is it ever touching 0? No. So since it's not touching 0, we leave an open bracket, and all of my y values are not going down, they are going up. So my range is from 0 to infinity. If we were to equal 0, everybody, if it were to equal to 0, then my range would look like that. If it were to equal 0. But these are never reaching. Are there any x-intercepts? Is it ever crossing the x-axis? Does it ever cross the x-axis? No. So there's no x-intercepts, but there is a y-intercept. What do we plot for our y-intercept? It was at a 0, 16. There's our y-intercept. There are no vertical asymptotes. There are no vertical asymptotes, but there is a horizontal asymptote. There's a horizontal asymptote at y equals 0. It's never crossing over the x-axis. So that's your horizontal asymptote. Is this graph increasing or decreasing from left to right? Decreasing. So you would say it's, by the way, this word down here is decreasing. It's decreasing. It's decreasing from negative infinity to positive infinity. It's always decreasing. All right? If you were to buy a stock, this is not what you would want to see. It just go continually down until it's worth pretty much nothing. And we don't want that. Okay? You would like to have the reverse of it, where you buy a stock low and it goes high. All right? So what I want you guys to do, use this function, make an accurate graph. Tell me the left-hand behavior, the right-hand behavior, the domain, range, intercepts, asymptotes, and whether it's increasing or decreasing. That's what I want you guys to do on your own. Okay? Hopefully, if you were not in class